circular motion where a body is given and that body is having some weight and that is whirled in a vertical circle making some revolutions per second. Okay, so let's say this is a body, right? Let's say this is the body with a mass m, right? And this is tied with a string like this, right? It's given that the body weighing this is whirled in a vertical circle making some revolutions per second. If the radius of the circle is 1.2 meter, find tension in the string. So that means this is the string, right? This is the string through which this body is tied up, right? And just hold this string and try to rotate it like this. Okay, rotate it like this. What will happen? You can see this body will follow a circular path, right? A circular path is followed by this body when it rotates in a circular motion, right? From this the position of the body will be like this and in this. So let's say it can be moving in a circular motion and it can be a clockwise motion, it can be anti-clockwise motion, depending upon the motion, from the direction of motion which you are giving. It all depends. Now this is the string, this is a string, that means let's say thread through which this body is tied up, right? Now it's given that the body mass is 0.4 kg. So here it's given that the body mass, the mass of the body is 0.4 kg. It's given. Okay, let me zoom a little. Okay, this is 0.4 kg which is given to you, right? Again, in a vertical making 2 revolutions per second. So this body is making 2 revolutions per second. That means that is the frequency. Revolution per second is the frequency. So we can write frequency is 2 revolutions per second is your frequency, and the reverse of the frequency is the time. So we can say the time period of revolution of this body across this circular motion is equal to 1 by 2 seconds, right? Because the frequency of revolutions of this body across this circular motion is 2, so the reverse of the frequency, that is 1 by f, will give you the time. So the time period of revolution of this body across this circular motion is 1 by 2 seconds, right? Now it's given that the time period, the mass of the body, and it's also given that a body weighing 0.4 kg is whirled in a vertical circle making 2 revolutions per second if the radius of this circle is 1.2 meter. So this is the radius, this thread is making a radius, and that radius is equal to 1.2 meter, right? Helenita, hello. So this is making a radius of 1.2 meter, right? Now, what is the question which is asked in this numerical? That when the body is at the top of the circle, so this body is just moving across this circle, and there can be different positions. It will be here, it will be here, it will be here. As this is rotating through the same string, right? It can be here. Again, it will move to this place also, right? And accordingly, it will move across the different positions in this circular path, right? So, in this question, it is asked that when this body is at the top, that means if this is the vertical circle and this will be the top position, right? So this is the top position, top, This is the topmost position, and this is the, tell me, this is the bottom position. Okay, so this is the position of bottom. Now in this question we need to find the tension in this string, right? So let us draw the free body diagram. Since the body is attached over here, you can see the tension will be acting like this, right? Tension, the circular force, the centrifugal, will be acting into this direction, right? So let us draw the free body diagram and the body is at the top. So top, at top, what is the position of the body? The body will be like this, and the centrifugal force which will be acting, I am saying about this position, position 1, it will be mv square by r, right? And this will be this mv square by r, this is the centrifugal force, right, will be acting on this body, and the string is tied in this direction, right? So there will be a tension into this string, let's say T, right? And across it, the weight of the body is also acting downward, that is mg, right? You can see here at this position, the tension will be acting downward because you are holding the string. Okay, so the weight and tension here, tension will be acting like this, and when the body is at this position, tension will be acting like this. Okay, now here, when the body is at the top position, the free body diagram FBD can be written like this. And when you see the equivalent forces which are acting, then from the free body diagram we can say mv square by r, right? This is the centrifugal force equal to T plus mg, right? This is the T, tension into the string. Tension in string, tension in string is equal to T, right? That we have assumed. So based upon the free body diagram, yeah, Helenita, you are saying something. Hello. So mv square by r equal to T plus mg, right? So this is the free body diagram. Based upon the free body diagram, this is the relation which we derived, right? At the top. So the value of tension can be calculated. How? You know the value of m. M is this 0.4. You know the value of r is 1.2. But what is the value of v? What is the value of v that you need to calculate, right? That need to be calculated. Since omega equal to 2 pi by t, omega, let us solve. Okay. Since omega, the angular velocity equal to 2 pi by t, right? Omega equal to 2 pi by t. So we can say for this t, of 1 by 2 seconds, we can see 2 pi divided by 1 by 2 seconds. So this will give you 4 pi. The angular velocity omega is calculated as 4 pi radian per second, right? This is the angular velocity. So which you can just simply 4 pi radian per second, right? Now at the top of this circle we have calculated, based upon this free body diagram, this equation is arrived. mv square by r equal to t plus mg, right? This one. So v square by r, when you replacing this v square by r, right? V equal to r omega. Therefore, mv square by r can be written as m into, in place of v, just put r omega, right? Then it will be r omega whole square divided by r. This will give you 1 r will be cancelled out. So this will give you m r omega square, right? So this will give you m omega square into r, right? So just put this m omega square r in place of this mv square by r, right? Then what we will be having? We will be having this equation as this much, m omega square r. Instead we can directly put up this formula at this place, okay, because this derivation I think you are knowing, but anyway we have explained it in details, so that in place of mb square by r you can put m omega square r. So m omega square r equal to t plus mg, right? This is the relation which is derived. Now you know the value of m, just put up the values. M is 0.4 into omega square. What is the value of omega which we have derived? 4 pi. So put it 4 into pi whole square into radius. What is the radius? 1.2 meter. So this is 1.2 meter. This is m omega square r equal to t plus mg. It's also given into the question the value of g, acceleration due to gravity, is 9.8 meter per second square, and m is 0.4 kg. So 0.4 into 9.8 meter per second square, right? So from here you can see, you can calculate the value of t. What will be the value of t? That means the tension into this string at this position when the body is at the top, that is calculated, that will be calculated when you keep t into the RHS and into the LHS. What we will have? We will have zero point 0.4 into 4 pi whole square. So just I'm not going into the arithmetic calculations. This will be 0.4 into 4 pi whole square into 1.2 divided by, no, is when 0.4 into 9.8, this will come into the LHS, this will not be divided by, actually this minus 0.4 into 9.8, this much of Newton. This much of Newton is the tension which is developed into this string when the body is at the top position. Here you can see when the body is at the top, the tension which is developed into this string is this much. Based upon the free body diagram, we calculated the value of this t. Now into this question, the second part is that during the rotation, when the body reached up to the bottom level at this point, what will be the tension into the string, right? So let us see. When the body reaches to the bottom position, what will be the tension into the string? At this point, we again draw the free body diagram at the bottom position, okay, as we did for the top position. This is the top position. This is the top position, right? Now the body will be looking like this, right? I'm just putting it within the screen. Yeah. So at the bottom position, at the bottom position of this mass, this body will be M here, and the weight of this body is acting downward, that is mg, and the tension which will be there into this string, that will be acting upward, isn't it? See this, right? So, and the centrifugal force, if this is the string, the tension will be acting into this string because you are holding it somewhere from here, and this is in rotation, right? So this will be T. Okay, T will be the tension into the string, and this will be the weight which is acting downward, and here another component will be there, that will be the centrifugal force, that is mv square by r, and you can also write it m omega square r, right? So these are the three forces which are acting on this body, right? Total three forces, you can see. So from this, based upon this free body diagram, FBD, at the bottom position, what we can derive, that total forces acting upward equal to total forces acting downward. Okay, so the total forces which are acting downward is mv square plus mg, and that is equal to T, and we need to calculate the T. So T equal to mv square by r or m omega square r, you can write anyone. Since we have derived omega, we will write m omega square r plus m into g, right? M omega square r plus m into g. This will give you the tension in the string which is developed at the bottom position, at the bottom position, right? Now this T is calculated. Let us see. Here T is calculated as m omega square. What is the value of m? Is 0.4 multiplied by omega square. Omega. We have calculated the value of omega. What is the value of omega? It's 4 pi. You can see here, right? So we will write the value of omega as 4 pi whole square into the radius. What is the radius? Is 1.2 meter. 1.2, right? This plus mg. What is the value of m? 0.4 kg into the value of g, that is 9.8 meter per second square, right? When you add both these values, you will get the value of T, and that much of Newton is your answer, which will be the tension which is developed into this string. This T will be this much, what we have calculated. Okay, so m omega square r plus mg will be the tension into this string when the mass is at the bottommost position, right? And this will be the value. Just do the simple arithmetic calculation, and this will give your answer. Thank you so much, students. Thanks for watching. Any query you can put up into the comment box. Yeah, thank you.